Ever wondered how vast our Milky Way is? To grasp its immense size, we first need to understand the staggering distances between the planets in our cosmic backyard, the solar system. Beyond lies a scale so vast, it dwarfs everything within our solar neighborhood. Our first stop is close yet significant. Our moon, positioned 400 kilometers from Earth. This distance may seem vast, but is a tiny step on the cosmic scale. Imagine boarding an airplane cruising at 1,000 kilometers per hour. A direct flight to the moon would take about 16 days. In terms of communication, light, zipping through space at unimaginable speeds, takes about 1.28 seconds to bridge this gap. This results in a slight delay in conversations of about 2.5 seconds for a message to travel back and forth, disrupting the flow of a chat and making timely communication tricky. This delay becomes more relevant as we set our sights on Mars. The red planet, at its closest approach, stands about 56 million kilometers away. That same airplane, if it could sustain a flight path to Mars, would take about 6.2 years to reach its destination. It takes light about 3 minutes to traverse this distance, translating into a communication delay of at least 6 minutes for a round-trip message. In space exploration, where precision is paramount, such delays aren't merely inconvenient, they could have critical implications. The Sun-to-Earth distance, approximately 150 million kilometers, a measure known as 1 astronomical unit. There was some confusion about why this distance isn't fixed. The reason lies in the definition of an astronomical unit, which represents the average distance between Earth and the Sun, not a constant. Earth's orbit around the Sun is not a perfect circle but an ellipse. This means that the distance between Earth and the Sun varies throughout the year. At its perihelion, or closest approach, Earth is about 147.1 million kilometers from the Sun, occurring roughly 2 weeks after the December solstice. Conversely, at its aphelion, or farthest point, the distance stretches to 152.1 million kilometers, occurring about 2 weeks after the June solstice. Interestingly, Earth is farthest from the Sun during the summer in the northern hemisphere, a fact that surprises many given the warmth of the season. The change of seasons occurs because of Earth's axial tilt, not the varying distance from the Sun. It takes light, the fastest entity in the universe, about 8 minutes and 20 seconds to traverse the vast expanse between the Earth and the Sun. As we journey further into our solar system, we encounter Neptune, the farthest planet from the Sun, located an average of 4.5 billion kilometers away, or 30 astronomical units. At this tremendous distance, sunlight takes 4 hours to reach Neptune. When Neptune and Earth align closely on the same side of the Sun, the distance reduces to 4.3 billion kilometers. Imagining a flight to Neptune at an airplane speed of 1,000 km/h, it would take an astonishing 490 years to complete the journey, highlighting the enormous scale of our solar system. Beyond Neptune's orbit lies a region filled with dwarf planets, with Pluto being the most famous, situated about 39 astronomical units from the Sun. Despite the vast distance, this area does not mark the edge of interstellar space. That boundary is defined by the heliopause. The heliopause is the outermost edge of the heliosphere, where the solar wind is stopped by the interstellar medium, mainly composed of plasma from other stars. Crossing the heliopause, we leave the familiar solar system behind and enter the vast expanse of interstellar space, where distances become truly mind-boggling. For example, Proxima Centauri, the nearest star to our Sun, is about 40.2 trillion kilometers away, equating to roughly 270,000 astronomical units. In this interstellar domain, the distances far surpass anything within our solar system, challenging our comprehension of our galaxy's scale. Within the Milky Way, the average distance between stars is about 316,205 astronomical units, underscoring the vastness of our galaxy. To grasp such astronomical distances, consider stars like Betelgeuse, one of the largest known, with a diameter exceeding the orbits of Mars or even Jupiter around the Sun, nearly 700 times the size of our Sun, or about 1 billion kilometers in diameter. Betelgeuse is so luminous that it is easily visible in the night sky, even though it is about 650 light-years away from us. To put this enormous distance in perspective, consider the daily routine of an average person who walks around 7,500 steps a day, covering roughly 6 kilometers daily. Historically, the average life expectancy was around 24 years, equating to a lifetime walking distance of about 50,000 kilometers. If we multiply this by the estimated 117 billion people who have ever lived over 200,000 to 300,000 years, humanity's cumulative walking distance totals over 6 quadrillion kilometers. Imagine if humanity passed a baton from one person to the next, each walking their lifetime distance. Collectively, we would reach Betelgeuse, yet this immense distance is still less than 1% of our entire galaxy. In this thought experiment, imagining humanity's journey across the distance between the Sun and Betelgeuse would span an unimaginable 2.8 trillion years. These numbers are so immense that they challenge our everyday understanding. Consider the Milky Way, our galaxy, stretching approximately 100,000 light-years across. While we can state this figure and use it in calculations, truly grasping its scale remains daunting. Our minds struggle to visualize such vastness. To aid comprehension, let's compress and scale down the Milky Way to the size of Earth. If we were to shrink the Milky Way, which spans 100,000 light-years, down to Earth's size, about 12,542 kilometers in diameter, we'd be reducing it by an astonishing 74 trillion times, 74,248, 394, 856,129 times to be precise. In this scaled-down galaxy, the Sun, with a real diameter of approximately 1.4 million kilometers, 1,392,000 kilometers, would shrink to less than the width of a human hair, around 18 micrometers, 18.7 micrometers precisely. Proxima Centauri, our closest stellar neighbor, would be just half a kilometer away, 0054 Fenderklam, while Betelgeuse, one of the largest stars visible from Earth, would be around 80 kilometers distant, 82.82 kilometers. In this miniature version of our galaxy, the Milky Way, spanning 100,000 light-years, remains a vast expanse beyond easy human comprehension. The last time light traversed our galaxy, our ancestors were early humans, unaware of the cosmic spectacle unfolding above. Yet, vast as it seems, our galaxy is just a speck in a universe teeming with an estimated 2 trillion galaxies. Each galaxy, with its unique stars, planets, and potential for life, enriches the narrative of our universe, revealing infinite possibilities beyond our own world.